For 60 years, when you picture an astronaut, you probably see a big, bulky figure kind of stiffly bouncing around, right? They're literally wrestling with their own suit just to move. Well, get this. That's all about to change. Today, we're diving into the next-gen spacesuits that are less like armor and way more like a second skin, designed to turn astronauts from just survivors into actual planetary explorers.
Just picture that for a second. You're on the moon. It's one of the most hostile places imaginable. Crazy temperatures, super sharp dust everywhere. The old way to explore it was to be sealed inside what was basically a personal tin can with arms. But this idea, this gets to the very heart of the revolution. A suit that actually moves with you. A suit that lets you do something as simple, as human, as kneeling down to get a closer look at something amazing.
And that's the core idea here, this huge shift in thinking. We're going from suits you have to physically fight against, like a 300-pound zombie, as one source put it, to suits that feel like they're a part of you. It's the difference between a spacewalk being this grueling ordeal you have to endure and actually living and working on another world. So let's see how they're pulling it off.
So, to really get why these new suits are such a game changer, we first have to understand the problem. I mean, those iconic suits from the Apollo and Space Shuttle days were total engineering marvels, for sure. But man, they were also incredibly limiting.
Okay, 280 plus pounds. That is just staggering. But here's the thing, the weight isn't even the hardest part. Inside that suit, you're basically in a pressurized bubble. So every single time you want to bend your elbow or your knee, you're not just moving your arm, you're fighting to compress the air inside that bubble. It was absolutely exhausting work.
All right, so that's the problem. Now let's talk about the solution. Meet the AXM, which stands for the Axiom Extravesicular Mobility Unit. And I want you to focus on that last word, unit, because this is not just a piece of clothing. It is a fully integrated personal spacecraft. And get this, you don't really put it on. Astronauts will literally climb into the suit through a hatch on the back, almost like they're getting into a tiny submarine. You just seal the door, the suit pressurizes, and you're good to go. This design is also a huge deal because it means you could have suit ports on a rover, letting you dock your suit to the outside and climb in, leaving all that nasty, dangerous moon dust behind. But the biggest, most profound change is all about how astronauts are going to move. This is where the engineering is just wow. It's finally going to let a human being walk and bend and work like a normal person on another planet. Remember that exhausting fight against pressure we talked about? Well, that was because of something called constant volume joints. Basically, the old suits were like balloons. If you squeezed one part, another part had to puff out. It made every movement stiff and robotic. The new suits completely rethink that entire problem. And this is how they're doing it. It's brilliant. Instead of clunky, rigid parts, they're using advanced fabrics that are layered to move more like human muscles and tendons. There's a totally redesigned shoulder bearing that lets you raise both arms straight up, something that was literally impossible before. And new joints in the hips and ankles mean astronauts can actually walk with a normal heel-to-toe stride instead of doing that classic Apollo bunny hop. And if you want to know what kind of a difference that makes in the real world, listen to this. During underwater tests, where they simulate low gravity, astronauts in the new suit prototypes were able to sprint. And what was their reaction? They were giggling in a spacesuit. That one detail tells you everything you need to know about the sense of freedom and just pure joy this new mobility unlocks. Okay, so the movement is incredible, but the revolution doesn't stop at the neck. The suit's helmet is being transformed from just a simple fishbowl into an augmented reality command center. An astronaut is going to have a heads-up display, a HUD, projected right onto their visor. They'll be able to see their oxygen levels, follow a glowing path up a crater, or even look at a rock and see its geological data pop up. They can track their crewmate as a little blue silhouette, even if they're behind a hill. It basically turns them into a super-powered field scientist. And the suit's AI is actually helping out. So imagine an astronaut is having trouble with a stubborn bolt. The suit's AI can sense that they're struggling. It'll project a glowing arrow onto their tools, showing them which way to turn. And then it'll vibrate the glove when they've reached the perfect amount of tension. It's like having a co-pilot built right into your suit. Of course, all this amazing capability is powered by some incredibly advanced systems in the backpack, that intelligent co-pilot keeping the astronaut alive. But, with great complexity comes new kinds of risk. So the biggest leap in life support is this thing called a swing beta-mind system. The easiest way to think about it is like a miniature, reusable chemical lung.
Instead of using disposable canisters to get rid of carbon dioxide, this system just scrubs the air over and over again, which means you can do spacewalks for 10 hours or even more. It's a total game changer. But here's the crucial trade-off. A super complex system like that regenerative scrubber, well, that's a potential single-point failure. If one tiny valve gets stuck, the whole system could go down. And those flexible joints? They're way more mobile, but they could also be more vulnerable to a puncture from a tiny micrometeoroid. The engineers have decided the trade is worth it, but the risks are definitely real. And this table really puts it all into perspective. Just look at the pre-breathe time. That's how long an astronaut has to spend getting adjusted to the suit's pressure. It drops from 7 hours down to just 1. That's almost a whole workday saved. Max spacewalk time goes way up. The payoff is transformative, no question. But you can see the risk shifts from a physical one, like decompression sickness, to an engineering one, system complexity. So what does this all add up to? I mean, all of this incredible technology, it all comes back to one simple, really powerful goal: completely changing the human experience of exploration. And this is the whole point. The old suits forced astronauts to spend most of their energy just trying to survive and fight the suit itself. The new suits are designed to just fade into the background, to free up the astronaut's body and their mind so they can focus on the science, the discovery, and just the absolute wonder of being on another world. And here's the practical result of that. More time outside means more geology, more experiments, more ground covered. The potential for scientific discoveries on these future Artemis missions is just exponentially bigger, all because these suits will let them have longer and much more efficient workdays. So, when that first Artemis astronaut steps out onto the lunar South Pole and kneels down with an ease that no Apollo astronaut ever could, and picks up a piece of ancient rock, they might whisper something simple, something totally human, something like, "Look at that beautiful thing." And what's amazing is what happens in that instant. The suit itself becomes part of the story. It'll hear those words, it'll capture the moment in stunning 8K, automatically tag the precise location of that sample, and then share that moment of pure discovery, live, with all of us back here on Earth. And that right there is the ultimate takeaway. For the very first time, the spacesuit is evolving from just a life support system you wear into a true exploration vehicle that you inhabit. It's a machine that will finally be able to match the incredible ambition of humanity's reach for the stars. It won't just keep us alive out there. It's finally going to let us live.